Good morning, friends. It gives me immense pleasure and happiness to be here again for the course Aircraft Systems. This course belongs to the 6th semester Aeronautical students. Today my topic is a case study on Full Authority Digital Engine Control FADEC system. My name is Dr. Yagya Dutta Dwivedhi, Professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have completed all the 5 units, and also this lecture is the last lecture for case study zone. In this 15th lecture it is, and the next lecture onwards I will be starting the definition and terminology belongs to the aircraft systems, and followed by, after that 5 lectures will be there, and followed by I will be discussing about question and answer related to aircraft systems as per the module. So each and every module, some 15 to 20 questions for every module will be discussed and replied. We have seen till now that aircraft systems can be divided into the 4 groups. First group is aircraft structural system or airframe system. Second group is aircraft vehicle system. Third one is avionics system, and fourth one is the missile system. So we can see that our vehicle system, it consists of electrical power generation, electrical power distribution, oxygen system, hydraulic system, pneumatic system, oil system, and many more. In module 5 we have discussed about flight control system and the engine control system. Here I am here in this lecture, and it belongs to the flight and engine both control. It is belongs FADEC, Full Authority Digital Engine Control. So it is belongs to the control, and that is to the engine control. Nowadays we have very sophisticated and modern aircraft. These aircrafts are equipped with a very sophisticated engine also. Day to day, as the years pass, engines, their efficiency is increasing, their size is reducing, their power production capacity is increasing. It is happening due to the modern design as well as a modern investigation of materials. Engine manufacturing is not so easy task. Only few countries of the world, maybe 4 or 5 countries of the world, are able to make aero engines. Still India is not able to make aero engine. For our LCA project, we are trying to get the technology from some other country. However, we have taken the US made GE engine for our Tejas aircraft. India has to go a long way to develop and design the aircraft engines. So we can see that it is so difficult task of the engine, and to have a very good engine, to have a very controlled engine, a new technology has come, and this technology is called the Full Authority Digital Engine Control, and in short it is called the FADEC. So today I am going to discuss about FADEC, and hope this will be quite interesting to all of you. In today's topics and the course outcome mapping, First one, I have introduction to FADEC. This is covering the course outcome of 6. Then we have the functions, course outcome of the 6, function of the FADEC, FADEC infrastructure. Then we have architecture of the FADEC, FADEC schematic diagram, and then advantages of the FADEC. This I am going to discuss in this lecture. This FADEC is basically using a lot of sensors, and these sensors are fed by the help of the computer, and this computer will further give signal to the actuators, and these actuators will work, and it is automated system. Nowadays most of the aircrafts, they have the FADEC, and even for our cars also, automatic driverless cars, they are also using the FADEC system nowadays. So I will go with the introduction first. Introduction to FADEC. Full authority digital engine control, that is FADEC means just that. So full authority digital engine control, that is called FADEC, means that there is no direct pilot control over the engine or manual control mode. So if you are using the FADEC, pilot do not have any control over the engine. Engine will be fully operated, fully developed, fully operational, and do all the functions without any intervention of manual control. If the FADEC fails, the engine also fails. So that is the very big drawback. So if the engine fails, if the FADEC fails, the engine will also fail. However, system redundancy makes it much less likely for a FADEC system to fail than a traditional magneto system. So the FADEC is made in such a way that there is no chance of failing the FADEC, and it is much superior to the traditional magneto system which we were using before development of the FADEC system. In fact, a double magneto failure is statistically more likely than a FADEC failure. So if you make the double magneto also, and if you compare with this FADEC system, the FADEC system is much better than the previously used magneto systems. So it is one of the best redundancy available as of now, the FADEC system, and it is very complicated also. I am going to discuss in this lecture about this. So FADEC systems are autonomous, means it is fully automated. It is self-monitoring, self-operating, and the redundant. Okay, so it is autonomous. Just you program the computer, and even nowadays landing and takeoff is also performed by the FADEC system. It is fully autonomous. It is self-monitoring. It will sense the atmospheric condition, wind velocity, temperature, density, if cyclone is there or any other type of weather conditions are there, all type of things it will capture and it will give to the computer, and computer will give the command, and accordingly all the controls of the engine will function. This is also a self-monitored and also self-operating, and then redundant. It is failure proof. Almost it is a best failure proof. That is the redundant. That is why these things is used, the FADEC is used nowadays in most of the aircraft nowadays. Okay, I have shown here the functions of the FADEC. So here we can divide into the 3 groups. FADEC will control the engine, that is called the engine control. FADEC will also useful for the airframe communication. Okay, it will also do the engine health monitoring. So this has got 3 functions. One is the engine control, Second one is airframe communication. Third one is the engine health. So this is the first one, this is the second one, and here is the third one. So these three functions it is performing. So if we talk about the engine control, the engine control is done by acquiring sensor data. Then it processes the control laws and then command actuation. So from the atmospheric, from the other places, there are sensors are fixed. These sensors will pick up the data and they will give to the computer. In the computer, data will be processed as per the control laws. These laws will be applicable and this will give command to the actuators. And this actuator will function and your quantity of fuel will be less or more as per this data. Second thing, airframe communication. In airframe communication, report engine status, receive engine power command. So this is the airframe. So report engine status and receives engine power command. Third one is the engine health monitoring. It will also monitor the health so that the redundancy of the aircraft is very nicely achieved. So it is engine health monitoring. So here is the diagnostic, then prognostic and adaptive. So here it is diagnosing that what problem is happening. Then it is in advance, it will do the action to rectify also, and adaptive, it will adopt the system as per the requirement. So these three functions, three zones of functions are here. One is for totally engine control, another is the airframe communication, and also it is monitoring the health of the engine. So what are the features of this FADEC? The control and monitoring of engine operation. So it is main function of this thing, control and monitor of the engine operation, dual channel and the redundancy. For everything you have the double system. So the redundancy of the aircraft and engines is very highly increased. Engine life monitoring. This will also monitor the engine life. It is also measuring the wear and tear of the gas turbines, compressors and all the equipments associated with the engine. It is monitoring. Record of engine performance parameter, and this is also recording engine performance. At every flight it is recorded in the recorder. Automated troubleshooting. If any fault is going to happen or it is already happened, it is automatic trouble or the problem is solved by the another standby system. Memory read or recall of engine data. It is also memory read, the full record of the engine, all performance, all parameters, all different types of activities are recorded for the engine data. Control of common engine problems. Those problems which are very frequently coming, this also is solved by the help of FADEC. Display of warning. These warnings will be displayed on the cockpit for the pilot. So pilot can also know that there is going to be some problem or some problems are already happened. Next, it is adapting as per the situation. It is also isochronous idle speed. So it will also help for this purpose. If you talk about the FADEC infrastructure, we have different types of infrastructure is needed for the different aircraft. So this infrastructure is divided in number of parts. Here, the first part I am going to discuss about the control operation in gas turbine engine. In gas turbine engine, how the control is operated. So this you can see here that here we have, this is the combustion chamber, I am writing CC, and here is the propeller, it is rotating, and from here you will get how much thrust is produce. So this thrust input is coming here, and the temperature fuel flow is going from here. Here we have the engine power setting computation. It is a FADEC here. So it is computing how much power is required. Here we have primary A and thrust target, and here thrust lever position. So as per this actual thrust, how much it is coming, it will sense here, and then it will target thrust is here, and accordingly this thrust lever will be operated for the system. If you see here, you will get the indicating in the cockpit. You will get maximum thrust, you will get the thrust limit and the thrust target. All will be visible in this screen, and accordingly the variation of the fuel, required fuel will be altered. Okay, so that is the objective of such type of control operation in gas turbine. So here fuel quantity will vary, and accordingly the RPM and the thrust, this all things will vary, and this is done by the FADEC, and this is called the control operation in gas turbine engine. So control in gas turbine engines, we can control the air, how much amount of air is required, that is the compressor entry. Next is the fuel control, main, auxiliary and starting fuel system. How much fuel is required for different starting, that we can also control. Starting and the ignition control, lubrication control, surge control through bleed valve. The surge of the engine is also very dangerous activity, in which your compressor will start giving abnormal pressure, and also the flow will start in the reverse direction, and also thrust control also can be achieved. The vibration of the engine also can be controlled and monitored through air and the fuel control. So this vibration is achieved by the inlet air and the fuel control. Thrust can be achieved by exhaust nozzle variation of the size and the area and other dimensions, it can be varied. Surge control through the bleed valve of the compressor, it can be reduced. Lubrication control, starting, ignition control, fuel control and air control. These are the control function of the FADEC. So this we have to keep in our mind. Now, simple chain of control, this is mechanical operation. How this mechanical operation is working, this we can see from here. So here is the FADEC at the last. Aircraft computer is here. Then we have the cockpit. Here the pilot is monitoring this. From here it goes to the FADEC computer. In FADEC computer, so many things are attached. Here we have the electro-hydro-mechanical control unit, and here we have the mechanical actuators. So from here the signal goes to the, here we have solenoid valve, here we have the position sensors, and here we have the servo actuator motors. These are the things. So this FADEC will give signal to the actuator motors, then, and this will be, some sensors are there, position sensor, it will give the position of the aircraft and their control, it will be fed to the FADEC, and from the FADEC a solenoid valve is here. This solenoid valve will operate the actuators. Here we have, it is called electro-hydro-mechanical control unit. In this, electrical, hydraulic and mechanical systems are used, and these systems will work as per the guidance of the FADEC system. From here, if you see, this goes to the mechanical actuator. From the mechanical actuator also we have the position sensor here. Position sensor 1 and the position sensor 2. Here we have the position number 5 here. So it will also sense and give the feedback, and it will also give the feedback to the FADEC that how much it is deflected, this actuator assembly. Here we have the gear driven mechanical pump. This will give the hydraulic systems to the hydraulic pressure to this mechanical control unit. Here we have the working fluid from the engine and the aircraft. So this fluid will go to the gear driven mechanical pump, and like this your hydroelectric mechanical, this unit will function. So this is a basic diagram for the layout of simple chain of control of the control operation, the mechanical system. Now electrical system. So here if you see, it is a electrical control system, and this is, we can see that here we have the FADEC computer like that. From here if you see the various inputs from the command to engine, from here it goes and comes. Here we have the various inputs from the aircraft, pilot's throttle in cockpit, display panel in the cockpit. This is the cockpit zone. Now from here we have the electro-hydraulic mechanical. It is the same type, but here we have double systems, signal coming and going, signal coming and going, and signal coming and going. In the previous one only one direction was there. These mechanical actuators are there, and from here this signal goes to this. Mechanical actuators will open or the close as per the requirement, and here this black, the green system shows the your electrical. So this has got double redundancy comparing to the mechanical one, because here if mechanical fails, electrical will take over and your system will work. So that is the advantage of the this electrical FADEC systems. So now what are the hardwares required for the FADEC system, and what are the software, and what are the other things required for the FADEC systems? We have to study and we have to understand. So we need a dual power supply, means one is the primary, another is the standby or the secondary. FADEC computers with logic circuits and the PCBs and the programmable memories are required. A set of servo actuating motors, solenoid valves, position sensors for every system control units, dual position sensors for actuators of every system. Here we should have the dual position system sensors. A set of electrical harnesses for every system, display panel with indicator, warning lights in cockpit, multiple engine RPM, pressure, and these are the sensors, these things to be used. So these are the items required for the FADEC hardware. So if you want to make the FADEC, these equipments are needed, and they are the hardware. Now I will talk about the FADEC software. In this we have EPR, engine pressure ratio schedule, for thrust over entire range of engine operation without FADEC computer failure. Next we have N schedule for thrust as per pilot's throttle, engine operation in case of limited FADEC computer functionality. So this EPR schedule, thrust over entire range of engine operation without FADEC computer failure. So in that EPR schedule is required. Then we need N schedule for thrust as per the pilot's throttle, engine operation in case of limited FADEC computer functionality. Here we should note that in case of certain degree of FADEC failure, there is an automatic mode switch over from EPR to N rating. However, if the failure disappears, the pilot can reset the system. So if these things are there, pilot can change from EPR to N, and this can be happen in partial certain degree of FADEC failure. So what we need input and what we need output from the different zones for the FADEC. So FADEC for aircraft, what the input need, FADEC need. So if this is the FADEC, these inputs from the aircraft and these inputs from the engine. So what are these? Ambient temperature. So what is the temperature of the surrounding? At what altitude your aircraft is flying? What Mach number your aircraft is flying? Angle of attack, impact pressure, landing gear position, missile rocket firing signals, etc. It needs from the airframe. If you talk about the engine, from the engine we need throttle lever position, RPM of the engine, turbine outlet exhaust gas temperature, exhaust nozzle area, fan duct flaps position, bearing temperatures, engine vibrations, engine pressures. So these are the parameters which we need from the engine, and these all parameters are extracted by the sensors, and these sensors are giving signal to the FADEC, and this FADEC, a computer operated system, will take the decision, and this will calculate, and accordingly it will send the signal to the operating actuator. So now if next I'm going to talk about the architecture, how this FADEC is made of. So here you can see this simplified architecture is typical of many dual channel FADECs. There are two independent lanes, lane A and lane B. So here we have a very simplified architecture is there for a typical FADEC system, and here we can divide this thing into two lanes, lane A and the lane B. So here you can see the engine fuel channel, engine fuel demand here. This, if you see here, engine thrust demand and engine fuel demand. From here it goes to the FADEC A line, and another is the FADEC B lines. Okay, this below one. FADEC B line monitors. Here the FADEC A line control and FADEC lane A monitor. So control and monitor is a part of the FADEC, and here we have the double system. Dual redundancy is obtained. If one system is failed, another will start operating. So each lane comprises a command and monitor portion which are interconnected for cross monitoring purpose and undertake the task of metering the fuel flow to the engine in accordance with the necessary control laws to satisfy the flight crew thrust command. The analysis required to decide upon the impact of certain failures in conjunction with other requires a Markov model in order to be able to understand the dependencies. Now, what are the features for military and the transport aircraft, especially in relation with the FADEC system? So here if you see that we need the feature, the compressor entry guide vane control for LP compressor and the HP compressor. So compressor entry guide vanes are required. Main fuel control, AB fuel control for core and for fan AB. Starting fuel control and the ignition control is required. Bleed valve control and the fan duct flap control is also required. Exhaust nozzle control. So these are the requirements or features of the military and the transport aircraft FADEC features. Here I am showing the schematic diagram of FADEC, a typical schematic diagram. I can see here that it is a pilot in cockpit. This part is pilot in cockpit. Here it is sitting. Then here we have the aircraft computer. Then here we have the power supply. This goes to the FADEC. Pilot is directly, it can operate the EECU, electronic engine control unit. Here is the FADEC. power supply, one goes to the FADEC and another it goes to the EECU. Starting and the monitoring, the control is performed. And this all input goes to the EECU. It is major component which is monitoring all the and the controlling all the engine parameters. So here this will go to the low pressure compressor, air inlet guide vane control, high pressure compressor, air inlet guide vane control, main fuel control, core AB fuel control, core fan AB fuel control, exhaust nozzle control, fan duct flap control, bleed valve control. So if you see here the previous one, these all controls are explained in this schematic diagram, and this is done by the help of the sensors. And here in the FADEC, it is a computerized FADEC and a very small component, but a very powerful, and it is able to perform all the type of tasks which the aircraft supposed to be performed. Further, we can divide the control architecture in different methods: centralized method, then distributed method. Okay, so I'm going to discuss about centralized control architecture. In this, a centralized system is working to make sure that the systems are working properly. So here we have the sensor 1, sensor 2, sensor J, sensor N, actuator 1, actuator 2. These are the actuators. So this sensor will give to the sensor electronics. This will also give to the sensor electronics, and this sensor will also give to the sensor electronics. From here, the signal will go to the bus bar. From this bus bar, the sensors will also, it will be communication, and the communication all will come here. Here we have the central processing unit or the memory. It is of the computer. It will go to the computer, and from here the FADEC, this is the FADEC, and this power will be supplied. This will go to the actuation of the electronics, and it will go to the actuator, and this actuator will operate the engine control or the flight control as per the requirement. So actuation electronics and actuation electronics, and different actuation 1, 2 and N. So there may be so many actuators, and also there should be 1, 2 and J. So many sensors. So as per that, it is called the centralized control architecture. So everything is controlled by one CPU memory system. If you see about the next, it is a distributed control architecture. In this, there is a little difference. You can find out here that here by the sensor itself, sensor 1, sensor 2 and sensor J, they will give to the sensor electronics, and from here it can come directly to the actuator. In that, it was all the signal will go to the CPU. From here it will go, but in this what happened, this will go to the communication, and this will be FADEC will be a separate system. From here the communication will go if any correction is needed, that time only. So it is a distributed, everything is not given to the FADEC, some part is given and remaining is controlled by itself. So that is the difference between the centralized one and the distributed one. This you can see here, a basic difference. Here these are not connected in this one, in this not connected here, but if you see here, this all are connected, each and everything is connected with the centralized system. So that is the difference between centralized system and the distributed system of the FADEC architecture. Now I will discuss about advantages of the FADEC system and why we use and why we should not use. So first and foremost, reduce the air crew workload. This is very much essential, because if the pilot is fully concentrating on flying up the aircraft, then pilot cannot see the safety aspect. Pilot cannot see what is happening surrounding. So the pilot in this type of aircrafts where the FADEC is fitted is mostly concentrating for the safety aspects from the operation, especially for the fighter aircraft. They have to see many things. They have to monitor so many aircrafts, missiles, rockets, and so many things, so that the pilot can concentrate on other issues, not only the flying the aircraft. Improved fuel efficiency by using the FADEC. It is 100% sensing all the parameters and it will fly as per the economical zone. 15% of the fuel can be saved. It is a huge amount. Due to faster, accurate engine control, no trimming is required. Reduced aircraft weight. By using this FADEC, the weight of the aircraft has been reduced. The size of the engine is reduced due to absence of heavy mechanical assemblies, no scattering of the pipelines and the electrical wiring. So everything is by the very accurate system. Wires and pipelines are too much reduced and the weight of the aircraft is reduced tremendously. Enhance engine life. The life of the engine is enhanced due to the engine operation in safer and the mean range. So in this, you cannot race the aircraft. You cannot give the acceleration as per pilot's demand. This FADEC will make sure that aircraft will fly an economical zone only. It will select the altitude, it will select the speed, it will select all the parameters of the aircraft, where it's supposed to fly, where it should give a sufficient economical flight, so that the profit of the company, the airline, can be enhanced. So that is one of the very good thing, that enhance engine life. If the engine life is enhanced, the cost of operation is reduced. Improved reliability. So in this, the reliability is also improved. The redundancy of the aircraft is very high and aircraft is very safe comparing to without FADEC operation. Minimum maintenance due to on-board computer guided troubleshooting. Aircraft can return to flying at the earliest. So in this, what happened? The maintenance is also depend upon the computer which is fitted on the aircraft. Computer will say what to do, what not to do. It is in previously we used to do by the help of the manuals, aircraft manuals, but now it is not like that. Your FADEC system will say that what component you have to do maintenance, what component you have to replace, what component you have to do some servicing. All these parameters are guided by the troubleshooting by the computer, and aircraft, the servicing time is tremendously reduced. The spare parts which we normally not required but we used to replace, that is not done if the FADEC is there. Isochronous idle speed leads to smoother engine starts. So during starting also a very isochronous speed is achieved and the engine is starting is very smooth and it is very reliable. So maximum performance in a combat aircraft or at optimum fuel economy in a transport aircrafts are possible after necessary adaptation programming of FADEC computer. So if you use the FADEC, maximum performance is achieved, especially for the fighter or combat aircraft. A huge amount of performance is needed. Aircraft has to maneuver, aircraft has to, all of a sudden it has to take off. If you see here, okay, this is the aircraft. It is flying like this. All of a sudden, pilot feel that there is a missile. It is coming with, and this all things pilot will get in a monitor, in the radar, and pilot will assess that what is the speed and what the angle it is coming. Pilot will start maneuvering the aircraft. It can go the spiral like this, it can do like this, it can go like this, so that the missile which is coming from behind or the forward, in any direction, the missile will be confused. Missile will not give, will not be able to do such type of maneuvers as your fighter aircraft can do. So if once the missile is crossed, coming back is very difficult task, and aircraft will be immediately it will turn and it will run away from there. So the aircraft performance in a combat aircraft at a optimum fuel economy also in the transport aircraft are possible after necessary adaptation and the programming of the FADEC computer. So if we program our computer in such a way that the fighter aircraft should get the best flying ability, the maneuvering capability, the combat capability, and the passenger aircraft or the transport aircraft should be able to fly in such a manner that it should give a best economical flight where fuel consumption is tremendously reduced and the profit of the company and the airline is increased without compromising the safety of the aircraft. That is the first and foremost requirement for any airline. It is also having the auto testing, which removes the need for test running the engine after minor maintenance work. So what used to be there in previously, if some small problem is there in engine, we used to run on ground so many times. So what happens, engine life will also reduce. So many wear and tear will be there. And fuel consumption, oil consumption will also increase. So nowadays the FADEC has made the auto testing system, and that system is so robust that it removes the need of running the aircraft on the ground without any fuel consumption or without any power use, and it is very reliable. Auto testing system is available on the FADEC system. So very useful as of now for the aircraft operation. But we have certain limitations of this FADEC, so that also we have to take care of before we go for any final conclusion. Pilot cannot override the FADEC control. That is the one thing. If it is a fully automated control system, FADEC, pilot will not be able to override. Whatever is given the feed, this will follow the same feed without any intervention of the pilot. If pilot want also to do something, pilot will not be able to do anything. In the event of complete FADEC failure, pilot left with no other option than having to fly with least performance, just sufficient to land safely. This limitation has been removed in modern transport aircraft by having 2 FADEC computers. So previously there used to be only one FADEC computer. In the event of the FADEC has failed, pilot do not have any choice, but it is got only the minimum performance. It has to go and it has to land only in the nearest available places. That was the scenario. It cannot go and fly, just sufficient to land safely. This limitation has been removed in modern nowadays by introducing one more FADEC computer for this system. So here I am, this is my message that safe takeoff and safe landing. Always do not take chance. Aircraft is very lovely flying machine, also very safe, but we all have to take necessary precautions for flying the aircraft. Not only the pilot, not only the engineers, everyone. The flight safety is for everyone. Always your passenger or you are the technician or you are any person on the dispersal or the aerodrome or airport, everyone has to take necessary precautions for safe landing, for safe takeoff and safe flying. So the FADEC is one of the equipment which gives a better flying capability, which gives a better controlling ability, it gives a better flight, it saves a lot of fuel. So it is very environmental friendly. It increases the life of the engine and whatnot. All the benefits you are getting by using the FADEC system. So here a small picture is shown here, and this says that safe takeoffs and safe landings always, and this is happening by the FADEC system. These are the references which I have taken from Google. That is the first one. And second one is the book, which is from Moyer I and the Seabridge A, Design and Development of Aircraft Systems and Introduction, AIAA Education Series, AIAA 2004. The most of the part is from the http://www.slideshare.net, GBRG FADEC Full Authority Digital Engine Control Final. This is the introduction which I have taken from the FADEC. So as of now, I have completed my 56 lectures, and in these 56 lectures, I have completed all type of aircraft systems related topics. Hope you all will be seeing my videos, watching my videos, and also understanding. If you feel anywhere I have done some mistakes, please let me know. I will be trying to correct it. So in this way, I am feeling that if anywhere I might have done, I am also human, I might have done some mistakes, let me know. I will try to rectify the mistakes and I will update as per your suggestions. Thank you very much. Here, any questions on FADEC, you are very well to ask. You are also, I am requesting to subscribe, like and comment in this channel. It will be my honor and the pleasure to reply your questions. This is my email, ydwidvi@gmail.com. This is my email. You are welcome to ask a question in this email, and hope you have learned very well. Thank you very much for joining this class, and be tuned. My next class will be definition and the terminology, and this will be 5 classes. I will be discussing different terms used in this course, aircraft systems, and this will be in general nature. Anyone can get the knowledge, and the first lecture after this I will be starting about introduction to aircraft systems, and in that I will go first on airframe systems. Airframe system, what are the systems and how these things are operating, and all the small definitions and terminology I am going to explain. So wish you all the best and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.